Okay, so let's look at the IGCSE Maths papers from January 2020. I think it's interesting to look at the last question in each paper. Let's take them in turn. So, paper 1H had this question for the last question, had an isosceles triangle. We've got vertices HJK and the point of each one, the coordinates of each one is specified. We've got two unknowns. We've got J and K. We're told that J has to be negative, which we need to pay attention to later. There's also a midpoint for the side J to K. The gradient of H to M is 2. We've got to work out the J and the K. So first of all, you've got to realize how the thing is oriented. So we've got HJ is equal to HK, so we've got two sides of equal length like that. So JK must be the base, and M is the middle point of the base, and H to M then will be from the vertex to the center of the base. And the gradient of that line we're told is 2. Okay, so how are we going to do this? We need to set up a few equations. So first of all, we can find that midpoint. So you have to remember to find the midpoint, 2 points, we have to find the average point, so the average of the x coordinates and the average of the y coordinates. So if M is the midpoint of JK, we need to look at the coordinates of J and K and average the x coordinates, average the y coordinates. So that's J plus 6 over 2, 15 plus K over 2. Okay, so that's one thing, and then we need to work out the gradient from H to M. So now we've got the point for M, the coordinates for M, and we know the coordinates for H. We can then do the change in Y over the change in X for those coordinates. Divide them, that's the gradient. So for example, 15 plus K over 2, if we subtract 1, then that's going to be 13 plus K over 2. And then our J plus 6 over 2, we're going to subtract negative 4, so let's add 4. So over 2, that's going to be adding 8. Okay, so we can now cancel the over 2 to give us 13 plus K over J plus 14, and we're told that equals 2. Rearranging that, we can then find one letter in terms of the other. So making K the subject, we find K is 2J plus 15. So we're going to keep that for later. Right, next piece of information, the length of the base, length of JK, well, that's root 80. Well, the length of the segment between 2 points, use Pythagoras on the coordinate differences. So J and K, so that's x coordinate is J for J and 6 for K. So the difference is J minus 6, square it, and then we've got K minus 15, square it, and that will be equal to the length squared, which is 80, the square root 80. Okay, so we can save a bit of time at this point by subbing out K from the previous result. So instead of K, we're going to have 2J plus 15. That works out quite well because we've got minus 15. So K's are gone, we've just got J's. Expand the brackets, going to get squares of J and J's and numbers. And we're just going to simplify that, tidy it up into a quadratic with 3 terms, collecting the J squareds, J's and loose numbers equal to 0. That does factorize. You can use your calculator to factorize that or to find roots. I've got another video on the channel which will tell you how to factorized by calculator, but the end result is that you will have two factors like this, and one of the answers from this will be j is a positive value, which we reject because we're told in the question j has to be negative, and the other is indeed negative, j is minus 2. And we put that back into the equation above, and we find k has to be 11. And that's for 6 marks. Okay, moving on to 2H, paper 2H, same session. Quite a complicated question. We've got sector, which is turned into a cone by sticking together sides O to A and O to B. We're told the height of the cone, we're told the volume of the cone, and we've got to work out the angle of the sector that the cone is made from. Okay, well, the volume formula that's in the formula book is a third pi r squared h. Let's say r is the radius of the base of the cone. So we make r squared the subject, so 3v over pi h. Put in the numbers that we've got. That tells us r squared has to be 192 over pi. And I'll just leave the pi in case that's useful. And let's see if we can find another relationship. So if we look at the cone, we've got the length of the slanting side plus the hypotenuse of a triangle. We've got h25 radius r. So we use Pythagoras theorem, L squared is 25 squared plus r squared. Can substitute in our value for r squared. And so that's just a number to work out. So from the green and the black ink, we can work out a number for L and a number for R. So far so good, we're going to keep that. Let's look at the sector. Well, I'll need the method there for the sector. You can use the length of arc or the area. I've gone for the area. So I've got x 360ths of the area of the full circle, which would be pi times this distance L. Okay, that distance L there is the same as this slant length on the cone. And the area of that sector is the same as the area of the curved surface of the cone. That's a formula given in the formula book, pi RL. So I make that equation. We can simplify, do some cancelling, make x the subject, and substitute the numbers that we found earlier for R and L, and we get a number 107, and that's 6 marks. Okay, 1HR, paper 1HR, the last question, unusual kinematics question. So we've got a particle moving on a line, the displacement from the origin t seconds is s meters, so we've got this displacement formula as a function of time. Time big T, the velocity of the particle p is v meters per second. Okay, v has got a condition on it. We need to find an expression for t in terms of v. Okay, so velocity coming from displacement, we need the derivative. So we do the derivative of that formula. So bring down the power, reduce the power by 1, and so we get a velocity formula in terms of time. Okay, from there there's different ways you can go. I'm going to go for complete the square to make t the subject. So I'm going to divide by 3 to make the complete the square easier. Then I can complete that square and collect my constants and make the square bracket the subject, collecting over common denominator 9, and then I can make t the subject by square root, subtract 4/3. Get a plus or minus on the square root. I don't want the negative, so I'm going to keep positive symbol, and there's the answer. 6 marks. Okay, final question in paper 2HR. Can be quite a tricky one, but there's a shortcut. So we've got this situation here we've got AC is parallel to OB, which is important. 4B on top, 6B on the bottom. We're told ANB is a straight line. Okay, so key fact we can use here is that the triangle at the top is similar to the triangle at the bottom. There's just a scale factor, and we know that because we've got two parallel lines, and we've got Z angles, and we've got opposite angles being equal. So we just need to divide 6 by 4 to give us the scale factor, which simplifies to 3/2. So this line here, O to C, must be split 3/2, O to N, N to C. And how can we use that to find what we want? Well, what we want is O to N. O to N is what we want. So O to C is straightforward. We're just going to do 3A plus 4B. O to N then must be 3/5. As a result of that scale factor, splitting the line 3/2, the O to N part must be 3/5 of O to C. So we do 3/5 of O to C. So it's 9/5 A plus 12/5 B, or you can express as a decimal if you prefer, and that is 5 marks. So there are the last questions in each of the IGCSE papers for January 2020.